good day. So we will be discussing gas effusion and diffusion. So effusion refers to the process for which a gas particles escape a compartment of a container or a system by trying to pass through a small opening. Okay, so if I have here a certain compartment and let's say there is a hole inside it, so effusion refers to the process for which these particles tries to escape using the small hole. Okay, and diffusion refers to the gradual mixing of molecules, so from one gas with one gas to the another. So this is similar to the diffusion of perfume scent in air. So the perfume particles will be have a strong scent at first, but as the time goes by, so the scent becomes weaker because the perfume particles diffuse together with the air particles. Okay, so in effusion and diffusion, we will follow the Graham's law of diffusion. So for both of the concept for effusion and diffusion. Okay, so at the same temperature and pressure, so the rate of diffusion of gases are inversely proportional to the square roots of the molar masses, which makes sense. For example, if I have here the effusion model, so it makes sense that bigger particles, meaning particles with higher molecular weight, will have a hard time to escape or to effuse to a compartment compared to the smaller particles or those particles with a lower molecular weight. Okay, so let's have an example. So a flammable gas is made up of only carbon and hydrogen and is found to effuse through a porous barrier in 1.50 minutes. So under the same condition of temperature and pressure, it takes an equal volume of bromine vapor to effuse at 4.73 minutes through the small barrier. So let's calculate the unknown the molar mass of the unknown gas. Okay, and let's try to suggest what this gas might be. So let's try to write all the given. So for bromine vapor, okay, so for bromine vapor, this so it has 159.8 grams per mole. So compared to the unknown gas gas compound, which is made up of carbon and hydrogen, so maybe I should write CH for it to be convenient. So so this CH has a molar mass of unknown, so it is unknown. However, we were given the time wherein these compounds, this bromine gas and this hydrocarbon gas, escape the or effuse through the to the barrier. So the bromine gas was able to escape or to effuse at 1.50 minutes. On the other hand, we have the bromine vapor that took 4.7. I'm sorry, this is for the CH. Okay, the bromine vapor took 4.73 minutes to escape the compartment. Okay, so based on this given, it is apparent that bromine gas has a slower rate
it has lower rate of effusion because it took bromine gas to escape the compartment at a longer period of time, meaning it has a lower rate. So maybe I should write R1, R2. Should I write R2 here. On the other hand, the unknown hydrocarbon gas only took 1.50 minutes to effuse, meaning it took shorter time, meaning it is faster. So it has higher rate. Okay? So comparing the two, if the hydrocarbon has a higher rate, meaning it took lower time to effuse, it is evident that the molar mass of the um, hydrocarbon is lower compared to the molar mass of the bromine gas. So let's try to solve. So take a note of this. So the rate 1 over rate 2 relationship is actually equal to the time 2 divided by the time 1 relationship. Okay? And using the Graham's law of effusion, the time the time 2 over time 1 is equivalent to the square root of the quotient of the molar mass of the substance 2 over the molar mass of the substance 1. Okay, so let's write this out. So it is interchangeable. So if you change the position of these two, you must also change the position of the molar mass. If you place 1 at the top, then you place 2 at the bottom, then you also need to interchange the other side of the equation. So you change molar mass 1 to the numerator and the molar mass 2 to the denominator. So with this, we have this equation by substituting all the given values. Okay? After that, solve for the unknown, the molar mass, which is 16.1 grams per mole. Which makes sense because it is smaller. The molar mass of the unknown hydrocarbon is lower to the molar mass of the bromine gas. The bromine gas molar mass is 159.8 grams per mole. So it is obvious that the hydrocarbon gas will escape the porous opening at a lesser amount of time, meaning to say at a faster or higher rate. So let's have an example. It takes 192 seconds for unknown gas to effuse through a porous wall and 84 seconds for the same volume of nitrogen gas to effuse at the same temperature and pressure. What is the molar mass of the unknown gas? So we will write the given. So the given is the unknown gas. Molar mass of the unknown gas is the unknown. The molar mass of the nitrogen gas is 28 grams per mole. The time 2 is the time of X took 192 seconds and the time of nitrogen gas is 84 seconds. So with this comparison, nitrogen gas took a lower amount of time to effuse, meaning to say it is faster, so it is expected to have a higher rate. Okay, so with this I should substitute. So T and Tx, so which is 192 seconds divided by 84 seconds is equivalent to the molar mass of the unknown, which is I place X, and the molar mass of nitrogen gas, which is 28 grams per mole.
Okay, rearranging. So I will raise the both side of the equation by 2. So this will be 192 over 84 squared is equal to x over 28. So solving for x, so this will be 28 grams per mole multiplied by 192 over 84 which is 2.28 squared. Okay. Okay, so further evaluate. So this will be 2.28 squared multiplied by 28. The answer will be 145 grams per mole. So this is the molar mass of the unknown compound.